Hi, I'm Mohak and today I'll be presenting on environmental impacts of dioxin. This presentation focuses on three main objectives. First, to examine the environmental and health impacts of dioxins. Second, to analyze trends in dioxin emissions and exposure using reliable data. And third, to evaluate regulatory responses and the effects of source control. I'll walk you through the five major visuals. First, we'll begin with emission trends over time. Second, look at emissions by industry. Third, the global source breakdown, a summary data table, and finally, a geographical map of key contamination sites. This line graph shows dioxin emissions in US from 1987 to 2000 across four categories: air, land, water, and products. What's immediately clear a sharp decline in air emissions from 15,000 grams toxic equivalent in 1987 down to 2,300 in 2000. This reflects the effectiveness of US regulations like the Clean Air Act amendments and tighter controls on incineration and industrial processes. Land emissions, however, stayed relatively stable, highlighting ongoing challenges with contaminated ash and soil. This bar graph compares dioxin emissions by industry in year 2000. The top sources are forest fires at 730 grams, backyard trash burning at 600 grams, and medical waste incinerators at 400 grams. This tells us that not all major emissions come from large scale industry. Household and accidental sources are still significant contributors. This pie chart illustrates the estimated global distribution of dioxin sources. About 70% comes from combustion processes, including waste incinerators and biomass burning. Metal smelting and chemical manufacturing contribute small shares, around 15% and 10% respectively. Natural sources and environmental reservoirs make up the remainder. Combustion remains the dominant concern globally. This table summarizes dioxin emissions by environmental medium across 3 decades. The most significant changes in air emissions, dropping over 80% between 1987 and 2000. Water and product emissions also decreased slightly. The data clearly shows that policy intervention has worked, but there is still room for improvement, especially regarding land emissions. This map shows major historical dioxin hotspots. In Seveso, Italy, a 1976 industrial explosion released a massive amount of TCDD. In Times Beach, Missouri, contaminated oil used for dust control led to mass evacuations in 1980s. And in Vietnam, Agent Orange use during the war continues to impact soil and human health to this day. These events emphasize how dioxin exposure is both a public health issue and long-term environmental problem. To summarize, dioxin emissions have declined significantly in countries with strong regulation. However, industrial and uncontrolled combustion sources remain key challenges globally. Dioxins pose major health risks, including cancer and immune dysfunction. Data driven policies and ongoing monitoring are essential to minimize exposure and protect public health. All data in this presentation were drawn from US EPA, WHO, and UNEP dioxin reports and inventories. Thank you.